Good afternoon. I'm going to tell you about an initiative that we had in Madrid.
Que es singular porque el proyecto
the project we carried out with APIs, with cryptography and e-signature. And other strategies we used before, but techniques that made deployment much more complex, much more insecure, and e-signature has simplified all this deployment tremendously. And I'd like to begin with an introduction to e-signature. Everything is based on two things. First of all, the key, the passwords. Here we have a private and a public password that are interchangeable, and everything that's encoded with a password is decoded with another one. And there are two characteristics here. If with these two passwords, if I keep one for me and I make the other one public, letting everybody know that it's mine, if somebody encodes something with my signature, only I will be able to decode it, to encrypt it. For instance, the triple Ds, this is how the PIN has encrypted bank or credit card, for instance, or account. This has to be distributed through all the ATMs in this country, so that when I use the card and I put in my PIN number, this must correspond to the one that's been encrypted within the magnetic band. Whenever something fails, the whole system fails. So asymmetric encrypting or cryptography solves the problem of password distribution. Now I avoid the problem of a secret password or a custody or something that, or for instance the blockchain thing. Some people don't know what to do with them because they're very afraid of losing them. But if we change this, that is, if I encrypt something with my private password, everybody will be able to encrypt it with a public password. And this public one needs to have been encrypted with my private one. And it's an operation that only I can do it. And this is where the concept of signature comes in place. If it's an operation that only I can do, and if everybody can check that I've done it, they can check that it's my signature. This is something that only I can do. Nobody can copy it, and it's easy to verify that my signature is my signature by any outside observer. And then we have another concept, and that is the digital print. The digital print, something that was referred to as a digital signature in the police, by the police forces. This is a larger figure, up to 212 bytes, and this is, for instance, the letter in the ID card, for instance. The good thing about algorithms in digital footprint, for instance, if I have one of these footprints that corresponds to a binary of certain megas or 512 bits, I cannot generate a binary that will have this print. This is something that's due to mathematical complexity. The first algorithms of digital footwear that were footprint or print that were used if it's through a given CRC, you can generate a binary with this CRC. The algorithms that were mentioned before, with maxi learning, MD5, that were used with SSL, I don't know if Internet Explorer 5 or 4, I don't know, in the 90s. That's the past, and now we use the algorithms that belong to SHA algorithms. SHA-1 was broken a few years ago, and now we use the SH2 family, and this is so this is not a security problem. And then we're working on the SHA3 family. The SHA2 has given length of the print. The longer the print, well, this is not much more secure. The national security scheme, which is a series of rules in Spain that sets the minimum standards that have to be met for security, speak of a given amount of bytes. If we combine the digital print with the e-signature, we get a couple of very interesting things. Only I have a private password, and only I can do transactions with a private password. Only I has the private password, so if somebody's done something with it, it must be me. So if I do an encryption and I encrypt the digital print of a document, since this print corresponds to a single document, and from the print I cannot generate a document with the present logarithms or algorithms, this means that this signature corresponds to one sole document. Just like my signature that's put on a document, and I cannot remove it and put it in a different one because it's going to be on paper and I'm not going to move it around. Same thing here. It's the print is related to the signature, and the print is related or linked to the document because it corresponds to it. And the print corresponds to one document. If the document is slightly modified, the digital print also changes. Thus, we ensure the integrity of a document. If a document comes to me and it's been signed, I can be sure that this document hasn't been modified. So, with some simple operations, we've achieved two things: the lack of repudiation of operations and the integrity of the message we're signed and we're sending. This translated into API is very interesting because this is not just good to identify the signee or the person who puts the signature, who owns the signature. In this case, there's a private password, but here we cannot ensure the integrity of the message. The message may have been modified, and if we have electronic signature, we control the identity of the one who originated the message and the integrity of the message per se. This taken to the world of certificates. I can generate a couple of passwords, and this is not a problem. Normally, we resort to a certification service supplier provider. In Catalonia, Sempe in the Basque country, etc., and the Ministry of Tourism or the digital agenda. Somebody tells us which institutions can issue certificates, public password, private password, and it also says who these data belong to, and this is something that's been verified in a register. When I have a register with a name that says Juan Español, and which has been issued by this is by a notary public. Well, this means that the person who obtained this certificate went to an office, showed to his ID, and controller made sure that he is who he says he is, and issues the certificate. So when I say that it's me, that I am what I mean is the identity. Is the identity, Spanish identity. That is, I have an ID on paper that says that I am Tomas, and because this is issued by the Spanish police, this certificate says that this is mine because there's an authority who's verified my identity with my passwords. Apart from this certificate that contains my passwords, my public and private passwords, has been signed by the institution that issues it. So I can check that Tomas has this public password because this certificate has been signed by the National Police Force. That are institutions that I trust, and and when I get when a certificate arrives to me, apart from it being signed, I can check whether this is valid or not. For instance, if I lose my certificate, I call the institution and I say, listen, I've lost it, so this certificate, is it in use or not? And I will say, no, it's been cancelled. So all certificates that suffer this vulnerability have been cancelled, even though they have been signed by the national police. I can call the police and ask, is this serial number valid or not? And they'll say no. So we've set up a very comfortable confidence or trust structure, because it allows us to verify who's originating a message and who this is, whether it's a legal person, a citizen, or a professional, or a notary public, and what we said about the integrity of messages. Another concept that I'd like to introduce here is digital software. The concept of signature that I mentioned before. We spoke about encrypting a digital print and not a whole document. Symmetric cryptography is extremely costly from the point of view of hardware. If a 15 mega PDF comes to me, I cannot encrypt a 15 mega document because it is too heavy for the computer. So there's quite a good solution, which is the digital envelope. So I randomly generate a symmetric password key password symmetric, but I will not give somebody the password. I won't say, listen, decode this with this password. No, what I do is encrypt this password with the public password. So when a message gets to this person, I can encrypt it, and he encrypts it. It's a single use, and this password is not going to be used again. So we have quite a good combination of symmetric cryptography and asymmetric cryptography. And there's an advantage, and that is that a digital envelope, there's one called PKCS7, and there may be one more than
cifrada n veces, una vez para cada destinatario, con sus claves públicas. Si yo tengo que enviar a Pepe, a Juan y a Rodrigo, puedo enviar dentro del sobre.
It may be more than one recipient. I can send the different passwords in an envelope in a message with several recipients. And I can also sign the whole message, because on the envelope I can generate a print and encrypt that print with my private password, so that the message will be encrypted for some specific recipients, and each one of them will control this with their password, and they'll know that it comes from me because it's been signed by me. So we've covered the whole cycle. We can define the recipient, and we can say who the sender is, where the message originated. We control the integrity of the message, that it hasn't been modified along the way, and also the confidentiality of the message that's been encrypted from the beginning.
Antes de seguir, por si luego nos suenan.
And before we go on, I'd like to say that the more broadly used algorithms are RSA. DSA is no longer used. The obsolete ones are MD2, MD5, SHA, and the algorithms, the digital print algorithms that are used right now are the SH2 family, SHA224, etc. And the future ones are SHA3 that are being prepared. The elliptical curve algorithms, for instance, are coming and will be here soon. MD2, MD5, SHA1 are obsolete, as I said before, because last window won't allow you to have them in the protocols. The present ones we have SHA2 family. Nobody uses them, well, because, this is more vulnerable. I recommend using SHA512, and SHA3 is being created right now. There was a tender, companies presented several algorithms, and the one who wins is called SHA3. There's IBM and others participating in the tender. And who can issue these certificates? And here we have the National Police, Social Security, but also private companies like Bank of Santander, and symmetric encryption algorithms. DS is obsolete. It was used in the banks in the 80s. It was cracked with a machine called D-Cracker. And this made the whole banking sector to create a new algorithm. And
coges 3 y lo pasas primero uno, luego otro, luego otro. Acabas de subir la complejidad. Y el que se está usando ahora es...
And the one that is used now is AES.
Y la firma electrónica tiene unas peculiaridades particulares.
Electronic signature has certain peculiarities. The RSA key doesn't give us information about who made the signature. When you create your electronic signature, you don't use your encoded signature. Only you include certain metadata. For example, my certificate with the public key, where I signed it, why I signed it. So these encoding algorithms are usually called PCK1. This is used in order to create the AD standards, advanced electronic signature. We have SADES, CADES, which is based on ASN1, which is a binary system, and then PADES, which is a CADES within a PDF file. These formats are European standard. And the American standard, CADES is CMS and PADES is PDF. As far as I know, it doesn't have a particular name. So we have this infrastructure for the electronic signature. And why are we interested in replacing SSL for this? SSL uses certificates. It's the same thing in the insides. But there are several problems linked to it. The SSL we use every day is the server SSL. I go into Google, and the bar, there is a lock. If I click on it, it says that this is a Google website because this has been established via electronic signature, and then verifying says that Google is Google. I know, like this, that Google is no other thing but Google. Then we have the SSL function that requests a certificate from the client as well. If you go to the tax authority's website, you are asked for a client certificate. In this case, we are using electronic signature, digital fingerprints, and a series of codes in order to cipher the transport in HTTPS. And this guarantees exactly the same thing as the electronic signature. There are several problems regarding this. First of all, transportation. SSL runs below HTTP. This means that my application doesn't allow me to control SSL. I can control the web server. And what I can do is have the web server passing certain information to my application in case of web traffic. That is, I can use an Apache front that can end up by sending me the data. I lose control. I cannot tell which certificates I want and which I don't want. It is extremely annoying. Anyway, I may be interested in relinquishing security in terms of transportation and using security for application on the application level, so to say. And with this, I gain legal support. SSL has electronic signatures underneath, RSA certificates and digital fingerprints. But if I use electronic signatures from my application, I can do that according to the law 59/2003. Transactions can have legal value that may be interesting for me at a certain stage. The application we created for the Spanish Mint was intended that, the goal was that the Spanish Mint would issue certificates that would classify people in a certain registration status. I don't want to specify which registry it was, but I'm not allowed to. Well, it was, let's simplify the example. I have a certificate saying I own a house, and this is certified by the Spanish Mint, and this is a legal document. But if the Spanish Mint knows that I own a house, the Spanish Mint is interested that this certification is also signed, because if it turns out that I don't own the house, that is a legal evidence. Because in the end of the day, it is the cadastre, the register, that certifies that I really own that house. So the Spanish Mint has a request from the registry requiring the signature. In the past, we used to go to a notary with a notary deed, and the notary would sign that this was so. There were also property registers. Remember, if you buy or sell a real estate property, you go to the register and you obtain a certificate with a traditional stamp and signed by somebody saying that this is so. But if I need to know through API that a certain real estate property doesn't have any encumbrances, if I am in trouble, I can go to the judge and said this AIP came from this institution and it has a signature, then this is something extremely important.
¿Cómo montamos esto? Que es a mí lo que...
How do we do this? This is something that I'm interested in. I was surprised because we'd been trying out this electronic signature for a long time. It took us very little to set it up. We have a couple of projects that do everything for us, and this is in JIT Hub, and this is something we use with public administration.
La mayoría tiene una aplicación que tiene una malísima prensa.
Well, people find it extremely difficult. You can go into the town council in order to get a residence permit or certificate or whatever. Very difficult to use. Even though web applications have problems, I must say that libraries are extremely stable, and they are audited every year by the National Center in order to make sure that there's no security breach, that everything is secure, and this works practically with any operating system. It's a very stable Java. Android lacks some of these things, but this works with Windows, Mac, Solaris, etc. And we have it with Java 7. Nobody uses Java 6 anymore. And I'm going to show you an example, and later on I'll try to upload them to GitHub in case anybody's interested. So we're going to be working with XML. It's a very standard way to send messages. The signature passwords, and I'm still being theoretical, I know, but the signature passwords are generated in password store or warehouse. This is only my password and it's only mine and nobody else can have it. So this must be stored in a given warehouse. So when Mint gives us a certificate, well, they don't give me a password. I generate my own password in my PC and will say, give me a public password because I'm the one who generates the private one. So Mint is the one that needs to provide me with a public one. This hasn't been generated, in the case of the police, this hasn't been generated by the police. It was generated inside the ID card and nobody else, nobody did anything with it. So vulnerability is very theoretical in this case, and with this. So when I use my private passwords in order to send a message, I must have access to a warehouse with passwords. There's an SH hardware model that generates and manages a series of passwords. I can have this in a smart card. I can have them in a little file. In fact, I'm uploading this from P12 extension, but I could have my passwords in smart card or something that is somehow protected. Mozilla and Firefox that has its passwords in software with a very high level of security. If you go in Firefox, there's something that's called activate certain mode, and within this certificates are done with an alias. So here I upload I never have a key, and I have a pointer in a real warehouse. Private password cannot come out, and when I encrypt it, it will be done inside the card, and some operations are very slow because it's a 15 megahertz processor with very complex operations, and generating is something that takes 2 or 3 minutes. And I see. So I obtain a pointer, I assign this and something comes out of this, and I'm going to try with an Eclipse.
Pues ha terminado ya y me debe aparecer en el temporal. Aquí está. Más o menos se ve. Esto es una firma SADES, esto es un mensaje firmado.
This is a signed message. If we look at the example,
he firmado Hola Mundo.
I signed Hello World, and this is what it generates.
Revisarlo un poquito, qué es exactamente lo que hay dentro de una firma.
What's inside a signature?
Hay una serie de referencias a nodos.
There's a series of references to nodes, etc. And this is the signature. What you see here is the encryption with my private password, and the rest are metadata that make up the standard format. This is the signature in the simplest possible format. This is the certificate that I've used in order to sign. These are metadata from the certificate. These are the data that I signed. This is where it is. These are compulsory metadata. For instance, who issued the certificate.
Y por si lo necesito, en este caso es el Colegio de Notarios. Bueno, la agencia notarial de certificación.
The agency of certification. We have a series of metadata here.
Por resumir, pues
just to summarize, date, etc., we can put in a lot of data. Where I signed it, it's legally binding. They were doing a transaction. For instance, when you write Madrid, September 30th, Madrid has a legal value. It's not the same to sign something in Madrid or in Sebastopol or in Mauritius Island, because obviously you're under a given legislation, and also the date is very relevant. Indeed, I can sign a contract, but I need to sign it. The date of the signature sets when the contract comes into force.
lo que haríamos en el otro lado. Esto estoy usando todo.
Well, next step is signature validation. This is all my GitHub code. Setting all this up with Java from scratch is really complicated. So the signature validation is made up of two steps. First of all, you have to validate the signature itself. That is, you take the public key, you check that the private key has been used, the corresponding one. I check that all the digital footprints match, so that I can verify that the public and private keys match together, and that the public key matches with the certificate within. Then I have to take the certificate and ask the issuer whether it is valid or not. This is a very serious issue. I've heard a lot of false things regarding the ROC vulnerability of ID cards. There is not a service of historic validation. So if I go to a validation authority to find out whether a certificate is valid or not, I cannot ask whether it was valid on August 13, 2016. If I ask if that certificate or if that ID card is valid, they answer whether it is valid today. This is a problem. We will see how it is solved. And I've been reading in several security fora that if I have a signature attached to my ID, but the certificates have been revoked, but my signature was before the revocation, or to put it in simpler words, if I sign today that I am the proxy of my company and I sign a document, I get fired tomorrow. How do I know that if the certificate saying that I am the proxy of my company was valid or not when I signed it? There's no way to know it. For that, there is another technology which is called time seals, and we will see it later on. For validation, there are two operations, validation of the signature and validation of the certificate.
Entre dos partes de un API, tengo que decir varias cosas. Primero,
if there is a dialogue between two parts of the API, there are two things involved. If I need to know somebody's identity at all costs, I need to use a provider of my confidence. Otherwise, I just go, okay, I know you are you, just give me your public key. But if I need a third-party verification, I need to use a provider. So the parties need to have certificates issued by providers. And then with that certificate, I can know if that is my user or not. If I use a certificate, I can obtain that ID, his ID number, And if I find that this ID is correct from a trustworthy source, then I can go on. We were talking before about the date of the signature, and it is very relevant. Let's go back to my example. If I'm trying to get a certificate stating that a real estate property doesn't have any encumbrances and that is signed, that is so on a particular date, and the situation may be different on a different date. So, for example, if the text I signed was on a particular date, according to the document, how can I verify that this date is correct? Who says that the 13th of January is really the 13th of January? That's when the time seals come into play. There is a further certification certifying the moment when the certification was signed, and this comes from a third party, not from the party originating the document or receiving it. It is a third party that certifies the time at which the document was signed. The disadvantage of this is that they are at a cost, and they charge by message. There are some TSAs which are free of charge, but their validity in Spain is limited. It's better than nothing, of course, but I think that in Spain there's only one legally binding time sealing authority that is for free, and it's the Catalan autonomous government. The Valencian government was giving it out for free also, but you need to request or to make more than you cannot make more than 40 requests in 1 hour or something like that. I've never tried it. Fortunately, our classes support the generation of a time seal. So what I do is to provide certain parameters, URL and the hash algorithm. This is because I don't give the entire transaction to the authority. I only send the digital fingerprint. Let's move on to another example now. The example I just ran is not summarized for PowerPoint purposes. It's really very small. Here is the signature validation. There's absolutely nothing. It just says that it's valid, as long as it's valid, of course. Correct signature, and here we have the certificate. If you allow me, I'm going to go backwards a little bit. When I validate a signature, I said that I usually go to the validation authority. This authority has two systems, one called CRL, where I download a list of revoked certificates within their period of validity. So I download a list with several serial numbers, and if my certificate is within that period of validity and also within that list, it means it's bad. And the list includes a code specifying why it is bad, why the code has been revoked, because it's corrupt or whatever reason. The validation by list of revocation is quite inadequate. Why? Can I download the list and reuse it? People who use the system download the list in the morning and use it for the entire day. So this gives me 24 hours of time to make mistakes. Because if I download the list at 9, those signatures will be considered valid for that entire day, although they have been revoked. According to the EU legislation, these lists need to include revoked certificates, even if they are out of the period of validity. This means that the size is going to increase hugely. So this includes not only Spanish ID cards, but also Basque cards. This means that the list contains 30,000 entries. What do I do? Do I download them every 5 minutes? Do I have to go through a list of 30,000 items? That's very complicated. There is another system called UZP, and I use it in order to find out whether the certificates have been revoked or not. This is a lot faster than downloaded a very exhaustive list, and this avoids also using up a lot of memory. So this OZSP tells me if the certificate is valid now, yes or no. CRL does the same thing. I cannot use CRL to find out whether a certificate was valid a year ago. It just gives me today's information. So we solve this with the use of a time seal.
En este caso, estoy buscando los aquí.
In this case, I'm going to run this one.
La URL del servicio de sellado de tiempo, en este caso el de
The URL of the time sealing authority from the Catalonian government, which is the only legal valid one for free in Spain. It is identified via an OID number, and it's not very clear where there are several policies. And what it says here is that what it certifies is the existence of a particular document in a particular moment, but they don't certify the moment of the signature. I can sign it today and send it for validation the day after. So the signature has one date, the stamp or the seal has another date, and there is a maximum deadline between the signature and the stamping. I can also sign today using tomorrow's date and sending it for stamping tomorrow, but that's not really relevant. So with this CAPCert data, I think the Wi-Fi is working. I'm going to delete the temp file. This is done. I'm going to close the older one, just to avoid confusion. The only difference between this document and the former one is that here we can see an encapsulated time seal. This chunk contains the document's digital footprint. Of course, this node is excluded because otherwise the time seal wouldn't work. And here I can verify what the message was and when it was sent. To see a little bit what it has inside, it's on base 64. I have the time seal here. And this is what I get back from the time sealing authority. It's not particularly clear because the time seal is signed, in this case, by CAPCert. I need to verify that the time seal has been issued by a trustworthy authority. Here we have the signature or the validation from the time sealing service of the Catalonian government. So this very simple step Just let me have the whole package. I can see who made the transaction. I can verify that the transaction hasn't been modified. I know when it was made, and this is based on evidence that provides legal security for transaction. This is free software, so the cost is zero. You are watching the examples. It's only 25 lines, and we can have authorities for free in order to avoid the cost of the paying services. I have the time sealing service, and this, for you to have an idea, a time seal is 20 cents. I think this is very, very expensive, because if we use a massive API, 20 cents is a huge amount of money. But I can use these free applications or even create my own TSA. They are sometimes sold with hardware using the GPS time and using the official time in Spain. This allows us to have the certainty of the time. All these examples are not using the confidentiality of the message, and this is something that SOAP is giving us. When I use SOAP security, I'm going to have electronic signatures, but I can have XLM encryption that will encrypt the message. But I prefer not using SOAP because it generates a lot of noise in the transactions, and if I want confidentiality, I use digital envelopes. This is an asymmetric encoding system where the symmetric code is paired to the public key. So it is really easy to generate a digital envelope. In this case, I take the public part of the certificate for the receiver and I generate the envelope. In this case, I'm not signing the envelope, but signing an envelope works in the exact same way. So here you can see that the generation of a digital envelope is that simple. And using this code, I can generate and open the envelope. We are talking about 90 lines, including comments, so it's really ridiculous. Opening a digital envelope, it's even simpler. I use my key store, open the envelope, and take out the data. It is as simple as that. An interesting thing that we need to bear in mind: XML is not as used as JSON as with regards to messages. The reason why is the canonization, since every slight modification in a message would cause a mismatch in the fingerprints, therefore invalidating the signatures. I need to remove any irrelevant data from the message, that is meaningless spaces, tabulations, etc. All these little things can cause the system to tell me that the message has been altered. This is the only problem we had at the Mint. We had XMLs without canonizing, and that's how they were assigned. And this was a problem because the /r/n of Windows were translated into /r/n into Linux, and it said that the signature wasn't valid. So I had to manually modify the message in order to validate the signature. So we have to canonize the XML in order to avoid this. You can canonize it with comments, without comments. There are several procedures. But if I have an XML, I don't mind if you have enter strikes or spaces because the digital fingerprint is going to be the same. However, in JSON, there is no canonical way. And spaces, for example, aren't significant. And there is no standard, whereas we have it in this case, in order to canonize JSON. So what I see what people are doing is to delete JSON as a Java class. If we all use the same JSON ng, the end is going to be the same JSON. So this forces you to have the same JSON classes everywhere. So at the end of the day, if I develop both parts, I need to put the JSON code within the code instead of using JRE, because if there is a change tomorrow in Java 10 and they introduce /0, for example, then there is a signature mismatch again. And now I'm going to tell you about what we gained here at the Mint. The project was set up in less than 1 month. It was up and running in less than 1 month. It's very simple. It's 60 lines of code per operation. And the keys were stored in a PKCS12 file. It's pretty unsafe, but they trust the source. We knew the message came from the register. And whenever we texted the register, they were sure that it came from us. And it was very clear that messages weren't manipulated at any point. I was also able to legally defend that I had received that message from the registry, and that is the reason why I had taken certain actions with my clients. With every API request, the cost was €9, and it was a massive service. At the end of the year, the invoice is going to be €700,000. So I made request for evidence, because in case of an attack, if the cost is €9, the call or the text, it is terrible. Imagine if it is hacked. It's going to be a huge amount of money if it is attacked via script. But the signature allows me to legally defend that everything that hasn't been signed by me cannot be charged. Then the legal part here was very important, as I say. Dates were very important, and all transactions had a time seal. So if a customer of mine wants to sue me because they say that the certificate doesn't match reality, I can go to the judge and say, well, this is the information provided by the Mercantile Register at that particular date. The signature has been validated by a third party, and this signature is validated by the Spanish law. Therefore, it's not my problem anymore. And so on and so forth. I've very rarely seen these systems, and there are usually terrible messes in SSL systems. I've recently seen these systems in the cloud signature systems of the Valencian government. When I went to perform a signature in the cloud, if I want to give powers to the Valencian government, well, this has security issues, because that petition from me needs to be signed as well, because there needs to be a way to prove that I requested that. So these power conferring things simplifies things a lot. So it's not about creating API security with 300 lines of code. What's important here is that we have the legal certainty that we cannot have from SSL or from other authentication tokens. Now I would like to review the Technology Transfer Center of the Spanish government. Now, due to recent legislation, the software generated in public administrations, the software that we all pay for, is now open source. There are certain projects, and most of the software here has very little activity. If you can see here, these are plain lines, but the signature project, which is called Clienta Firma, is quite active. Here you can see that it's been updated 2 hours ago. And here you can see that there are commits almost every day, almost every week. This is not a dead project. It's not a software that the tax authorities released and then forgot about. No, it is alive, it is very active, and it's used in several different projects. So this was all for me. Thank you very much for staying, and do not hesitate to ask me. I will now give you my address. So I'll be happy to collaborate with you. I don't have a contract with tax authorities or the Ministry of Industry. I do it on a personal level. I help people setting up signature solutions. I'm not trying to sell anything here, but I think they're pretty good. So if you believe that I can help you setting up this sort of infrastructure, please don't hesitate to call me, to ask your questions, or to invite me wherever you decide fit.